Let's bring up the general equation for a reversible reaction. So A and B in this case are the reactants of this reaction, and C and D are the products. But say if I wanted to make substance C, I wouldn't want it to keep reacting back into A and B all the time. So I need to disturb or manipulate the equilibrium position. And this can be done by changing the pressure, concentration or temperature of reactants. A French guy with the name Le Chatelier developed a principle to help you understand and predict what will happen if various conditions were changed in a reversible reaction. He said,
if a dynamic equilibrium is disturbed by changing the condition, the reaction moves to counteract the change.
So let's start with concentration. If you add more substance A, the system will respond by removing it, by turning it into more C and D. If substance B was cheaper than substance A, you might decide to add extra B. Alternatively, you could remove C as soon as it is formed. The reaction will respond by replacing it again by reacting more A and B. Removing a substance as soon as it is formed is a useful way of moving the position of the equilibrium to generate more products. Now let's have a look at changing the temperature of a reversible reaction. Suppose the forward reaction is exothermic, one that gives out heat. The backward reaction would be endothermic, one that takes in heat. If the reaction was 300 degrees Celsius, what would happen if the temperature was lowered to 100 degrees Celsius? According to Le Chatelier's principle, the reaction will respond in such a way as to increase the temperature again. But how can it do that? If more C and D are produced, more heat will be given out because this is an exothermic change. The extra heat will warm up the reaction mixture. Increasing the temperature will have the opposite effect. The reaction will move to get rid of the extra heat by absorbing it in an endothermic change. This time the backward reaction is favoured. So what about the effect of changing the pressure on the equilibrium position? Let's have a look. This really only applies to gas reactions where the total number of molecules is different on each side of the equation. In this example, there are 3 molecules on the left, but only 2 molecules on the right. Pressure is caused by molecules hitting the walls of their container. If you have fewer molecules at the same temperature, you will have a lower pressure. And according to Le Chatelier's principle, if you increase the pressure, the reaction will respond by reducing it again. It can reduce the pressure by producing fewer molecules to hit the walls of the container, in this case by creating more C and D. And the opposite will happen if the pressure is decreased. The position of the equilibrium will shift to the side which produces the most molecules. In this case, to the left of the equilibrium sign.